This is part 5 of the Math 310 Final Exam Review. I'm Joy Zeigler. Let's get started. The product of two consecutive positive integers is 8 more than twice their sum. What are the integers? Two consecutive positive integers, an example would be 3 and 4. Notice that when you have 3 and you add 1 to it, you get 4. We don't know what these integers are, but we know that one of the integers is just one more than the other one. So we'll let one of the integers be x, and the next one will be x plus 1. And we're going to use the clues in this question to come up with an equation that we can solve. Product means multiply. I'm going to put a times there, not to be confused with the x. Positive integers will be important later on. Is 8 more than, so more than means addition. Twice means 2 times. Their sum means addition. And is means equals. So let's write down what we see. The product of two consecutive integers, so we're going to multiply these integers together, which we don't know what they are yet, is equal to, so we've already taken care of this one, and well, we haven't taken care of the positive integers yet, but we've taken care of the is. So now what is it? It is 8 more than, so we're going to add 8 to whatever we do next, twice, 2 times their sum. So we're going to add together the integers, which are x and x plus 1. So that's our equation that we have to solve, and let's clean up x plus 1, and we'll call it 2x plus 1, and just get rid of that. Now let's start distributing. X squared plus x equals 2 times 2x is 4x, 2 times 1 is 2. So now we have x squared plus x equals 4x plus 10. To solve, we need to set everything on one side of the equation and make it equal to 0. And we do this by subtracting 4x and 10 from both sides of the equation. And we get x squared minus 3x minus 10 on the left equal to 0 on the right. So we know how to do this. We can factor this quadratic and find a solution. And to factor it, we need two numbers that multiply together to give us negative 10 and add together to give us negative 3. And so that's going to be 2 and negative 5. When you add those together, you get negative 3. So we write x plus 2 times x minus 5 equals 0. And according to the zero factor property, when you have two things multiplied together to equal 0, then one of those things equals 0 or the other thing equals 0 or both. So we will get a solution if x plus 2 equals 0 and if x minus 5 equals 0. So in other words, x can equal negative 2 or x can equal 5. But we're looking for one integer, so which one is it? And we look back at the problem, and here's where the positive comes into play. It tells us we are looking for a positive integer, so we can discard the negative 2, and our x equals 5. Our other integer is x plus 1, and that's going to be 6. So if we take 5 and 6 and plug it into the equation we had earlier, we should get the a true statement. So here is our equation. Let's plug in 5. Well, let's just read this. The product of two consecutive integers. That would be 5 times 6 should equal 8 more than twice their sum. Well, their sum is 5 plus 6 is 11. So does 30 equal 22 plus 8? And it does. 30 equals 30. So we've checked our work. Professor Harvey can grade the final exams in his classes in 5 hours. If his assistant helps him, together they can grade the exams in 3 hours. How long would it take the assistant working alone? So we'll say Professor Harvey takes 5 hours, and the assistant, we don't know, but together they can get the work down to 3 hours. So we pull out our trusty work equation, which says 1 over the first time of the individual, 1 over the second individual's time equals 1 over the time that they can do it together. Well, we don't know one of the individual times, so we're going to call it x. So we have 1 over 5 plus 1 over x equals, and the time they can do it together is 3. Now our job is to find the least common denominator, which in this case is going to be 15x, and we're going to clear the fractions by multiplying everything by 15x. So we will multiply, we're just going to multiply through. We're not going to do 15x over 15x, so we're going to multiply 15x, 15x, and 15x. And in the first case, 5 goes into 15 3 times, x goes into x, and 3 goes into 15 5 times. So what we have left are 3x plus 15 equals 5x. So subtracting 3x from both sides, we get 15 equals 2x. And then when we divide 15 by 2, we get, we'll go over here, 7.5 equals x. So the assistant would take 7.5 hours. Okay, 42 is to simplify this, and we're going to simplify it by changing it to a radical. Now, the denominator of your exponent is going to be the index of your radical, and the numerator of your exponent is going to be the exponent that you raise the radical to. So when we write a radical like this, we write that it's a squared. We don't even have to write that too, but we will. So we're taking the square root of 169, and we have the choice of putting the cube here, or, which makes more sense, putting it out here, because this way we can take the square root of 169 pretty easily. It's 13, and we get 13 cubed, which we can plug into our calculator, and 13 cubed is 2,197. Is the following relationship between two sets of numbers a function? If so, what is the domain and what is the range? Quick lesson on functions. If you think of a Coke machine, and the button you push is your X, and or your input, and what comes out is your Y, or your output. So if you push the button for Dr. Pepper, then you want Dr. Pepper to come out. If you push the button for Dr. Pepper, you don't want Sprite to come out. Now you could have two Dr. Pepper buttons and you want both of those buttons if you push either one to produce a Dr. Pepper. But you don't want a Dr. Pepper button to produce a Sprite. So what that says is for the input button you produce, there is only one output that can come of it. You might have two of the same inputs, or you might have different inputs. Like in this case, you have this one and this one. This could be one of your Dr. Pepper buttons, and this could be another one, and they both produce Dr. Pepper. You see, that's okay. But what you couldn't have is this Dr. Pepper button producing Dr. Pepper and Sprite. In this case, all of your input values, your negative 5, 8, and 3, they all go to one value. They don't then go to two values. You don't have two lines coming from them. So that's okay. So that means this function works, and so it is a function. And the domain is your input. So this is the domain, which is negative 5, 8, and 3. And your range is your output, which is going to be 7 and 12. A boat can go 24 miles upstream in 3 hours. In the same amount of time going downstream, the boat can go 36 miles. Find the speed of the boat in still water and the current of the water. So here you have a big old river, and the boat is going downstream with the current. The current's going this way. So the boat is going faster this way. When the boat turns around and tries to go upstream, it's fighting this current, so it's going to go slower. So going downstream, it can go farther in the same amount of time than going upstream. Now there's a relationship between distance, rate, and time, and the relationship is that distance equals rate times time, and we're going to use that to solve this problem. Now we're going to set up a table so that we can visually organize our information, and we're going to set it up for the two cases of going upstream and going downstream, and we're going to set it up based on this equation. So here's our table where we have distance equals rate times time, and we have downstream and upstream. So let's fill in as much as we can. We look at going downstream. Going downstream, we know that the boat is going 36 miles. So for distance, we can fill in 36 miles. Going upstream, the boat goes 24 miles, so let's fill that in. And we know that going downstream, the boat is going to go as fast as it would in still water, plus it's going to get a boost from the speed of the current. So let's call, we'll call S the speed of the boat in still water. And then in addition to that, we have the current. So the rate for going downstream is going to be the speed of the boat plus the current, and the rate going upstream is going to be the speed of the boat minus the current. And this is the key to solving this problem, is to express your rates in terms of your speed of the boat in still water plus your current or minus your current. And then time is 3 hours. So we have distance equals rate times time, and so we have going downstream, we have 36 distance equals rate, S plus C, times time, 3. Now let's divide both sides by 3, and we get that 12 equals S plus C. Now let's look at going upstream. In upstream, when we have distance equals rate times time, I'll do that in black, we have 24 equals, and this time our rate is s minus c times time, which is 3. And when we divide both sides by 3, we get that 8 equals s minus c. So now we have two equations. We have 12 equals s plus c and 8 equals s minus c. Let's line them up. Here's 8 equals s minus c. If we add these two equations together, we get 20 equals 2s, and notice that the c's go away. So if we this is just like elimination. So if we divide both sides by 2, we get 10 equals s. That's the speed of the boat. Now we can find the speed of the current by taking either of these equations. So let's take 12 equals s plus c. We'll write it up here. 12 equals s plus c. So we know 12 equals 10 plus c. And if we subtract 10 from both sides, we get that c is going to equal 2. And that is the speed of the current. So 10 is s, speed of the boat, and 2 is c, speed of the current. So let's check and see if that works. We're going to go look at our table again. 36 should equal s plus c rate times time. So let's see if that's true. Does 36 equal s plus c, which is 10 plus 2, times time, which is 3? And yes, it does. So 36 equals 12 times 3, which is 36. Now let's check the other case for upstream. Does 24 equal s minus c times 3, which is time? So 24 would have to equal 8 times 3, and it does. So that means these numbers are correct for the speed of the boat and the current. And that is your last problem on your final exam review. So make sure that you can do these problems without help. Rewatch the video, pause at the beginning of each problem and work it, and then check your work with the video. Good luck, and let me know if you have any questions.